Today's date is Monday, January 27th, 1/27, 2020. We are doing the Pythagorean Theorem challenge today after doing a bunch of different proofs on Thursday and Friday. Who wants to read our objective from today? And I did not pass out these cards. I'll just have to memorize it then. I didn't see whose hand was first. Julian.
Use the Pythagorean Theorem to solve the word problem.
There it is. So I'm going to be giving you some problems. See if you can utilize that theorem. And by the way, what is the Pythagorean theorem with a quiet raised hand? Gunnar.
A squared plus b squared equals c squared.
A squared plus b squared is indeed equal to c squared. A and b, it doesn't matter what order you have them in, as long as these are the legs and this is the hypotenuse. Then you are doing it correctly. And by hypotenuse, I just mean the one that is opposite of the right angle, or the one that looks diagonal is another way of kind of thinking about it. All right, so, and all of the students that were used in these examples were from last year. So who wants to read example number 1? Someone that still has their imaginary card. Those two people. Jenny, go ahead and talk about Brian.
Brian is swimming in the pool from his starting position. He swims over to talk to Emily, and then he swims to Martine to hang out. Finally, he swims over to Cheyenne to give her back the $1 he borrowed. How far is Brian now from his original starting position down to the nearest 10?
All right, so we have a picture all ready for us. We're trying to figure out this entire length that he was from his starting point. So if he has to go back to where he started, swim all the way back, how far is he going to swim back? What is this diagonal length? Does anyone have an idea of how we can find that answer? Let's do 5 more seconds of thinking by ourselves, and then I'm going to have you guys pair up and share your thoughts, and then we're going to share your thoughts.
8 seconds.
And all right, so everyone talk to at least one other person. You can have a group of 2 or 3. How are you going to find that entire diagonal length? Talk now. Should be loud in here, hopefully.
Multiply. Eight seconds of
All right. We've had some good sharing. Quiet raised hands. There should be more of them now. How are we going to find his entire distance, that diagonal distance? Still only one hand. Oh, that's not good. 2 hands. Andres.
So I have an idea
Okay.
that we can do. We can combine the lengths. Like Martine, instead of Martine and Cheyenne 4, like it could be the hypotenuse, and it could be 3 squared plus 5 squared. Instead of that proportion.
3 squared and 5 squared. So you're doing this length and this length to find this diagonal right here.
Yeah.
That helps to find that diagonal, but it doesn't help to find this diagonal. So a good attempt. You still get your imaginary participation card taken. Fernando, talk to us.
So you could do like 3 to the power 2 plus 4 to the power 2 equals x to the power 2.
So you're doing this length, and then this is a somewhat unrelated triangle.
Bro, I don't even know.
Not quite. And I will give you guys the answer, because it makes sense, like, oh, if I just had 2 there, and then that one was 3, and then I could find that entire length. But I didn't give you that. So make 2 triangles, 1 triangle. That is the general idea. So here's your 1 triangle that you can think of. Go ahead and extend this line, and you can now see this is the hypotenuse of this giant triangle, and we can find the lengths of that giant triangle. This length of the leg on the far right with a quiet raised hand is what? Sergio? 5. And this length on the bottom of the entire leg is what, Monse? Ooh, careful. The entire length, 4 plus?
7.
7, yes. So 3 and 4, you can carry the 4 down here. So an entire length of 7. So my new triangle that I'm really talking about is a triangle that is 7 by 5, and I don't know what that is. I'll call it C or X, whatever you want to call it. And that is a right angle. So we can set up our Pythagorean theorem from here. Quiet raised hand, who can set that up for us? Someone that has not participated yet. Jose? Equals C squared. Thank you. Another quiet raised hand. I need you to square 7 and 5 and then add them together and then square root them. Josie. 7 squared. 7 times 7.
49.
Perfect. 49. I'll actually do this in a different color. 49. And then let me zoom in here so I can see what I'm doing. 5 squared. 25. And that's still equal to C squared. Now let's go ahead and add those, Josie. The 9 and 5 makes what? 14, so I'll carry the 1, 4, and then I'll carry the 1 up here. 2 and 4, and that carried 1 adds up to 2 plus 4 plus 1. Yeah, 7 is equal to C squared. And then how do I undo the square, Josie? Last step. Ooh, it's not divide. Really close. It's, if I have the square, I square. You can give it to someone else if they.
Jessica has it.
Is there anyone that can help out? Josie? Jessica, you want to help her out?
You square with both of them.
Square, say it again.
Square with them.
Square
Root.
root both of them. Yes, there it is. Thank you. Square root both of them. Square root is the inverse operation of squaring, and therefore the square and square root cancel out. I'm left with C, which is what we want, is equal to just the square root of 74.
Wow, you're smart. I mean, hard work.
Thank you. So I guess the question is, can the square root of 74 be simplified? So for example, if I had 72, the square root of 72 off to the side, that's equal to 36 times 2, or rather the square root of 36 times the square root of 2, which means that is equal to 6, oops, what happened there? 6 square root of 2. Can I turn square root of 74 into something similar to 6 square root of 2? You will need to simplify your answers on Khan Academy. So can the square root of 74 be simplified?
No, sir.
And to figure that out, we can do a factor tree. We might have our final answer, but let's go ahead and do a factor tree. What times what is 74?
36 times 2.
36 times 2 is 72.
Oh, wait, never mind. I just copied you.
36.5 times 2.
Ooh.
Not quite, and I should be seeing a quiet raised hand.
Found it.
I'll give you a hint. One of them is 2. The square root of 2, rather. Square root of 2 times the square root of what is 74? Gunnar?
37.
37.
Wow.
And then from there, I can't move any farther because 37 is a prime number. So our final answer is just the square root of 74. But it wants us to round to the nearest tenth, which means we don't enter the square root of 74. We actually type that into our calculators. We say, okay, square root of 74. By the way, this is how you do it on Spotlight Search. You type in SQRT, and it tells you that the square root is 8.602325, etc., etc. And I'm rounding to the nearest tenth. With a quiet raised hand, is that rounding to 1 or 2 decimal places? Quiet raised hand. Sergio. Tenth is actually 1. Hundredth is 2, and thousandth is 3. So, Sergio, round to the nearest tenth then. It's 8 point. You got this. 8 point. There's 1. I'm rounding to 1 decimal place. That means I cut off right here, and then I round either this to 6 or 7. If this was a 5 or a greater, then I would round up to 7. Because this is less than 5, I'm going to round this to 8 point. Sergio? 8.6. I'm evaluating. This is 8.6. I'm rounding to 1 decimal place, and because this 0 is less than 5, I'm saying this is 8.6. So our final answer, write it and box it, is 8.6. Box it.
8.6.
All right, let's try example number 2. And you guys should not be shouting out answers on Sergio. A, that's breaking the class rule, and B, that's putting too much pressure on him when he's already under enough pressure. So sorry about that, Sergio. You're looking really sharp in your glasses, though. Example number 2. Who wants to read? Someone that hasn't participated yet. Who hasn't got in yet? Eder!
A relative is about to make a fence in his yard. He wants to put it between 2 trees and show in the sketch below how long will the fence be.
Perfect, thank you. All right, so another kind of harder problem. I'm letting you think about this on your own for at least 10 seconds. How are we going to figure out this diagonal length right here? What are we going to do? Obviously, there needs to be a right triangle in there. All of today's lesson is about a right triangle and using the Pythagorean Theorem. So draw that right triangle in your mind, or maybe on your notes, and then figure out the lengths of that triangle. All right, now, question, yeah, Sergio.
Is it 20 from the tree to...
Yeah, so this length right here is 20. This length right here is 15. This length right here is 20. So, talk with at least one other person. You may stand up. You don't have to stay seated. Go ahead and stand up. So, be careful. You can knock over my condom. Go ahead and talk with at least one other person. Discuss a strategy, if not the process, of finding that hypotenuse. All right, go ahead and take your seats again. All right, I need a quiet raised hand. I think everyone is in now. Everyone has their imaginary, they've either read the objective, the problem, or done some sort of math, right? Cohen, did I forget about you?
Yes, you forget about Cohen.
Sorry, Cohen. All right, the pressure's on you now, Cohen. How am I going to solve this problem? You had your chance to talk to a few people. Where is my right triangle, Cohen? Okay, you may call on a helper, but I'm going to come back to you so you can eventually answer a question. So call on someone, Cohen.
Come on, show us your work, please.
All right, Gunnar, show us our right triangle.
Right triangle?
Yes.
Tree?
Top tree or bottom tree?
Bottom tree.
Bottom tree, okay.
To the corner of 15 and 20.
Like that?
Yeah.
Okay.
And then there's a right angle right about there.
So right about there.
Yeah.
You are correct that that is a right triangle. Unfortunately, this right triangle doesn't really help us to find this diagonal because we've created an additional diagonal, another hypotenuse. But good guess. Fernando, talk to us.
Can I go up there?
You may go up there. It is much easier to explain when writing.
Jose taught me this. Alright, so what if you just like...
A right triangle. Okay, there's our right triangle. Yeah, thank you. You can erase the work. So I'm going to toss it back to Cohen. I'm not done with you yet. There's our right triangle. So Cohen, what are the legs of this right triangle? I'll give you the easy one first. This leg right here is perfect, 20. What about this leg on the bottom? 5. Exactly, 20 minus the 15. All right, Cohen has given us, or Cohen and Fernando have given us our right triangle. I was making sure I didn't mistake you again. I
Got my name.
keep doing that. So if you guys want, you can draw your right triangle again out to the side if it's confusing. This is 5 by 20, and we're trying to find this length. I'll call it x in this case. You can call it a, you can call it heart, whatever variable you want to use here. And we need to set that up. So Pythagorean Theorem, I want you guys to be able to do this on your own now. Because we've had an example. I set one up. Well, I think it was Jose that set this one up, right? I need someone else to set this one up. Well, all of you to set it up on your own, and then we'll come back and reconvene to make sure that we did it correct. So find x, check with the neighbor, make sure that if it's a square root that it is simplified. Good luck. Something, yeah, you're close. All right, so here we are. I need a quiet raised hand to set up this problem for me. Andres.
So you can do 5 squared plus 20 squared equals c squared.
You're using c instead of x?
Yes.
All right, I can scratch that out and say c equals c squared. Keep going, Andres.
And then 5 squared is 25 plus 400 equals c squared.
Equal to c squared. And adding those together.
425 equals c squared. And then you take the square root of them both. Is it 212.5 times 2 equals 425?
Not quite, because you want to have a perfect square in there.
So it can't be like a decimal.
So I'll leave this as square root of 425 for now. And then the question is, how do we simplify this radical? Fernando?
So there's 17 quarters with 425, right? So the answer's 17.
You're really, really close. So
Fernando.
I agree that 17 times 25 is 425. 425, I can't speak. How do I know that? Well, I know that there are 4 quarters in a dollar.
And a dime.
That's what I did.
And I know that if I want to go up to $4.25 rather, to get to $4, I need to multiply by 4. So this is going to be 16 quarters in $4. And then I need to add another quarter. So 17 quarters will make $4.25. So 17 times 25 is indeed 425. And then from here, I just leave the radicals on both of them. Well, I know what the square root of 25 is. That actually turns into 5. So my answer is 5 square root 17 is equal to c. And that is what I'm looking for. And it didn't say to round or anything. It just said how long will the fence be. The fence will be 5 square root of 17. If you want to have an approximation, we could say 5 times the square root of 17, which is the same thing as the square root of 425. See, if I do subtract the square root of 425, I get 0. They're both the same number. But the square root of 425 is 20.6, and I'm just going to round one decimal place, 20.6. So I can say this is approximately
So on Khan Academy, it would be
20.6. It depends on what they're asking for. If they're asking for a decimal approximation, you'll say 20.6. If they're asking for just what is the answer, it'll be 5 square root of 17. All right, questions on example number 2? All right, we're on to example number 3. All right, I need someone that is very good at pronouncing Louvre.
Gunner.
Gunner, go for it.
The Louvre Pyramid.
Lower.
Louvre. The Louvre Pyramid is a large glass and metal pyramid designed by Chinese American architect I.M. Pei. Pei? Would that be Pei?
Sure, pay. I don't know.
It is located in the main courtyard of the Louvre Palace in Paris, France. The base of each triangle's face is 34 meters, and the height of each triangle's face is 27.5 meters. What is the length of the edge of the Louvre pyramid?
Yeah, a hard problem to pronounce. Is it a question, Andres?
I think I know what the answer is. I think it's 3.14.
That sounds a lot like pi, but I don't think it's 3.14. That would break the triangle inequality theorem. But so let's go ahead and annotate what's happening in this problem first of all. That's the hardest part. What is it even talking about? And by the way, this is a real problem. I just Wikipedia'd this and said, okay, well, what's a triangle that we could actually solve in real life? And if you've ever gone to the Louvre, which is like that art gallery that has the Mona Lisa, I think it still has the Mona Lisa, and all that other cool fancy art that you get to walk through. This triangle is out front in the gallery before you walk in, so if you see this, you'll be like, oh, Mr. Sindel told me about that. Anyway, this also goes underground as well, so you can walk underneath this and see what's going on. It's kind of cool. I think there's a smaller triangle underneath, or smaller pyramid underneath.
Isn't there one of those in Las Vegas?
Yes, and it is copied from the one in
There's a
France.
lot of copies.
No, I think that one's
The
copied.
Statue of Liberty.
Anyway, let's go ahead and annotate this problem. The base of the triangle's face, this base right here. You can't really see that. Maybe if I use yellow/orange. This length right there is 34 meters. The base of that triangle is 34 meters. And the height of the face of the triangle, so this height right here is 27.5. So I'll say 27.5 for that length right there. And I need to find the length of the edge. So this length right here, I'll do this in red, I suppose. This length right here is the one that I'm trying to find. That's our x, or I guess we can say that's our c. We've been using c as our variable most of the time. So if I were to redraw my diagram, I have this. I have, that is a not high quality triangle. I have a triangle that is isosceles, and I know that the height of the triangle is 27.5. I know that the entire base down here is 34. That's this entire length. And I'm trying to find that hypotenuse. Again, same as before, I need you to think about this by yourself. How are you going to solve for C? This is also a right angle because it's isosceles. How are you going to solve for the variable C?
I don't think that's right triangle. Yeah, I don't think that's right triangle.
It is. I promise you it is.
If you draw 3D, it is not a right triangle.
So that's not the edge it's talking about. You're right. That right there is not a right triangle. It's talking about this length right here. If I do a line from the center of the base to the top, then that equals right.
I see.
All right.
So I did it wrong.
Question, Sergio.
Is the top right triangle?
It might be. We don't know.
If it is, can it help us?
If it is, it definitely gives us another way to solve this problem. I actually don't think it is.
What are we setting it up?
You guys are solving it on your own for now, and
Can
then
I set it up?
when we call on people, yes, you can. I need you guys to talk to at least one other person. If you actually, yeah, just as a blanket statement, talk to at least one other person. You're pairing up to share your procedure, seeing if everyone is on the same page.
I don't know if this will happen. Yeah, it would be 44. But it's not a regular.
Exactly. All right, Fernando, you said that you wanted to set this up for us. Talk to us.
Alright. Alright, so what you see, you take half of 34,
Okay.
and then you get 17,
Why do we need to do half of 34 again?
because you're only solving for one half of the triangle.
Okay, so let's only solve for that half. So that half over here is going to be 17. Keep going.
And then you do 17 plus 25.5.
17 plus is 27.5, right?
Yeah, and then equals C, and then you square all of them.
And then square each of them. All right, perfect. Yeah, you set it up. Thank you. And that is the hardest step, knowing that you need to divide 34 by 2 in order to get just one of the sides. You only want one right triangle instead of 2 right triangles. And this one is definitely a calculator problem. So you can use the calculator on your laptops. Those calculators up there, just make sure you turn them to the right spots. 17 squared is also up here. 17 squared is 289. 289, and then I don't know what 27.5 squared is. 27.5 squared is 756.
What?
756.25. That's equal to c squared. I'm going to add those together. So I have 756.25 plus 289. That's 1,045. 45.25 is equal to c squared. And then finally, I need to square root that number to get c by itself to isolate our variable. So if I take the square root of that number, we get 32.33. I guess rounding to one decimal place, it would just be 32.3. 32.3. What are our units again with a quiet raised hand? Are we dealing with feet here, Jose? Meters. 32.3 meters. And does that make sense with the picture? Let's do like a reality check. If this length, this entire base is 34, this edge is 32.3. Yeah, that seems in the ballpark. That sounds about right. If we got like 1,000, we'd probably be wrong. If we got something that was like 2, we'd probably be wrong. But we got like a nice number. That makes sense. So go ahead and box 32.3 meters. Final answer. Give me a fist of 5 on our objective. How well can you use the Pythagorean theorem to solve real-world problems? Let's go around the room really quickly, starting with Jose. 4.5, 6. That's a weird way to give me 6. 4, 3, 4, 4,
Oh,
8, 3, 3.5, 4, 9, and 3.
Wait, teacher, it's 8.
Oh, it looked like a 4 to me.
So is that a teacher?
It's not a teacher. All right, and that concludes our notes.